In this course, we'll be learning about and using a database. Once you know how to work with a database, you'll find many ways to put your knowledge to use. A database is an entry that provides for the storage and organization of related data or information. For example, a phone book or cookbook can be considered a type of database. Those books store information and let you easily look up facts. For example, the telephone number of a person or company, or a recipe. A database can be implemented so that it runs on a computer system. Here are some examples of computerized databases. A bank uses a database to store your account information. Airlines use a database to maintain flight schedules and reservations. A college uses a database to manage enrollments, courses, and class schedules. Employers use a database to store employee and payroll data. On this slide, you see some of the types of databases that you might encounter. A flat database, sometimes referred to as a flat file, is not really a database. Instead, it is a text file in which each fact, sometimes referred to as a field, is separated by a comma or by a tab character. When you type the tab character on your keyboard, you don't see a character, but the tab is recorded along with the data, and a computer program can work with the tab. Flat files are typically used to export data from one database and import it into another. You'll learn more about exporting and importing data later in this course. A relational database organizes data into tables. A table is defined in terms of its columns, which contain the individual facts, and the collection of columns, called a row. A table can contain no rows, or potentially millions or billions of rows, depending upon the amount of data that is stored. Columns in a relational database can be designated as key columns and can be used to locate individual rows or groups of rows. This course is all about using SQL with a relational database, so you will learn a lot more about how to work with these features. Non-relational databases are sometimes referred to as NoSQL databases. These types of databases are typically used to contain what is called unstructured data. For example, text, tweets, and other data that is not easily reduced to individual facts. One of the most widely known NoSQL database systems is MongoDB. Finally, a hierarchical database organizes data into parent-child relationships. This type of database was one of the earliest database management systems. Although hierarchical database systems have been replaced by relational database systems in many applications, the hierarchical database type is still used in some applications. A relational database management system, or RDBMS, is a database management system based on the relational model. The relational model was invented by Dr. Edgar F. Codd in 1970 at IBM's San Jose Research Laboratory. A relational database organizes information in tables. A table consists of columns, which contain individual facts, and rows, which are a collection of columns or facts that have a common usage. For example, a table that contains data about a college course would include columns for the course ID, title, and description, but a column that contains the telephone number of the college would not belong in the same table. One of the big benefits of using a relational database is that data in two or more tables can be used in terms of its relations. For example, on this slide there are two tables, professors and courses, and another table, course catalog. The professor's table contains two facts, a professor ID and the professor name. The course table also contains two facts, the course ID and description. The course catalog combines data from the professors and courses tables to show what courses a professor teaches. In the course catalog table, the course ID is based on the course ID from the courses table. The professor ID is based on the corresponding column in the professors table. The when offered column is defined in the course catalog. You'll learn how to work with these types of data and relations in this course. As you might know, there are many different relational database management systems available from a variety of vendors. One of the first commercially available relational database management systems was Oracle, introduced in the late 1970s. Oracle was one of the first to feature the then new SQL language. SQL is sometimes pronounced as SQL and other times as SQL. Some other commercial relational database management systems are SQL Server from Microsoft and DB2 from IBM. When PC processors, memories, and disks became more widely available in the late 1980s, vendors introduced RDBMS systems that could run on PC or Mac operating systems. Two of these products are Microsoft Access and FileMaker. Finally, with the widespread adoption of the Linux operating system, open source database systems have become popular and widely used. Two of the most well-known open source database systems are MySQL and Postgres. In this course, we will be using MySQL. There are versions of MySQL for Windows, Mac, and Linux. To finish up, we'll look at some of the goals of an RDBMS. Practically all of the currently used RDBMS systems provide features that achieve all of the goals shown here. A RDBMS is often selected based upon how well it implements the features for a goal. Storing and retrieving data is the most fundamental goal of any RDBMS. In addition to being able to enter data into the system, the RDBMS must provide for the retrieval of the data and changes to the data, including removing data from the database. To prevent or mitigate data loss, an RDBMS system provides for the recovery and backup of the data that it contains. Consistency and integrity is another major goal. This is normally done by the person who designs the database, a job that is often performed by a database administrator or DBA. One of the primary ways to ensure database consistency and integrity is by using normalization techniques, which will be discussed in detail later in this course. Finally, data security is a critically important goal. Ideally, only people with a need to know would be able to access or change data in any database system. To help achieve this goal, the RDBMS system has built-in features to assign permissions to tables and indicate the degree of access that a designated user or group of users will have.